Hello, welcome back. We are still working on Chapter 4, Section 1, Graphing Relationships. Now we're going to look at example number 2, and from the hardcover textbook, it's page 231, which I think would be page 6 on the PDF. I didn't write it down, so I'm not looking at the PDF, so if I'm wrong, it's okay, just scroll through it. What we are going to do is we are going to draw a graph from the written words. Now in the last video, we matched the words with the graph, so the graph was written for us already. In this case, we're actually going to draw the graph from scratch. So before we can draw the graph, and actually I can start by drawing the axes. So that's my y-axis, and that's my x-axis. And you're probably wondering why I call it x and y. That we will get into that, okay? And I'm going to put an arrow here. That arrow tells me that it's increasing to the right. I'm going to put an arrow here, which tells me it's increasing up. But last problems, this was time. And then this was temperature in one example and speed in another example. In order for us to draw this graph, before we can get started and draw what goes in here, we need to know what these measurements are. And since they change, a measurement that changes is called a variable. So I could also say I need to know what these variables are. So let's look in this problem and see what's being measured and what could be changing. So Simon is selling candles to raise money for the school dance. For each candle that he sells, the school is going to get $2.50. I'm going to get a drink of water. Sorry about that. And he has a total of 10 candles that he can sell. So it's not going to go forever, all right? So what are the two things that are in here that can be measured or counted? Well, he has 10 candles. That also means that he could sell no candles, 0, or 1, 2, 3, 4, 5, 6, 7, 8, or 9, 10, up to 10 candles. So one of the things that we have here is the number of candles that he could sell. I totally having flashbacks of selling stuff in the middle school when people were selling candy bars or other stuff to raise money for clubs. This club's selling candles, okay, for the school dance. Now, what's the other thing that can be measured here? Well, I see a number. What does that number represent? $2.50 is how much each candle sells. $2.50 is a measurement of money, okay? So the other variable would be how much money that he's going to make. And other ways of describing it could be cost. Sometimes people say total, which is a way of saying total amount of money that you're going to get. However you want to say it, but I want you to understand that it is going to be how much money you have. Now the question is, which one of these goes here and here? So this is where we get into the idea of, and it's not actually in this section, it's the next section, but we get into the idea of independent versus dependent variables. So which one causes the other one to change? And we look at it first, we say, all right, well, what does he have first? He has candles. If he sells one candle, he's going to make $2.50. If he sells 2 candles, he's going to make $5. 3 candles, he'll make $7.50. So how much money he makes depends on how many candles he's going to sell. Now, that word depends, like I said, this will be a big part of the next week's section. But that part depends tells me that's the dependent variable which goes on this section. So I'm going to put money right there, okay? If you look at the book actually says the amount earned, sorry, it's hard to write sideways, in dollars, which is just a different way of saying that's how much money you're going to make, all right? Down here, this will be the number of candles, and I'll use the abbreviation with that was used way before Twitter, number of candles, right? So because I do have numbers here, I'm going to put a scale on here. So if I go 1 candle you're going to make 250. So 1 is going to be 250. And because my marker is a little thick, it's a little hard to see. 1 candle is going to be 250. 2 candles, 3, 4, 5, 6, 7, 8, 9, 10. And then $5, $7.50, $10, $12.50. So I'll write 10 right here. $15. This would be 5. And then $17.50, $20, $22.50, and $25. So 2 candles is going to make them $5. 3 candles is going to make $7.50. And 4 candles is going to make $10. And then if I had graph paper, this would all be lined up a little bit better. But I'm going to just sketch it here. I'm not too worried about being perfect or precious. I just want the idea. And then this one right here. This point right here represents 10 candles for $25 total dollars. 10 times 250 is 25. Okay? Now here's the big idea here, all right? Is this continuous or discrete? 2 big vocabulary words that are probably brand new for most of you. All right? If it's continuous, I'm going to connect the points. So I would draw a line through all these. Okay? And if it's not in a straight line, I would draw a curve. If it's discrete, I leave the points. So if this is discrete, I'm going to leave it. The idea is this, okay? Continuous means that there's measurements between the points. That's why I connect them, right? So you can break the measurements into smaller parts. And you can keep breaking them, keep breaking them, keep breaking them. So for example, one continuous variable is time. Because if I measure something in hours, I have smaller measurements. I have minutes, I have seconds, I have tenths of a second, I have thousandths with a th of a second. All right? So time is infinitely increasing. There's always a measurement between other measurements. Discrete, there is nothing between the measurements. Now what's measuring over here? Well, the number of candles. So 1 candle is going to cost $2.50, 2 candles are going to cost $5. We just talked about that. What if I wanted, or is it even possible, could you buy 2.37942 candles? Is that possible? 2.37942 is about right there. But if you said to Simon, hey, this is how many candles I want 2 and part of another one. He's going to look at you and say, I can't do that. Just buy 3 and don't use it. All right? So you have to round up to the next one or round down if you don't want the part of it. This is impossible. You're not going to buy that many candles. You can't have part of a candle. So this right here, this data is discrete. And because it's discrete, we leave it. We don't connect the dots. Now that is very, very, very complicated, and I totally understand it. The whole idea comes from, can you have something in between the points you already have? If I kept going, if I said 5, 6, 7, 8, 9, 10, can I have something between the 4 and the 5? Can I have something between the 5 and the 6? And since these are whole candles, that doesn't work. So let's do another problem. We'll show this one. Angelique's heart rate is being monitored while she exercises on a treadmill, right? She may have possibly some medical condition and they want to find out how her heart's working. While walking, her heart rate remains the same. So she's walking on a treadmill and her heart rate seems to be doing okay. As she increases her pace, so her doctor or technician says, all right, let's speed it up a little bit, her heart starts to rise. So as she starts to run, or any person actually starts to run, your heart's going to beat a little bit faster until you become like a pretty strong athlete, and your heart will increase, but then it still stays kind of low. Heart rate monitor is something that the athletes check. Okay, back to the problem. When she begins to run, her heart rate increases more rapidly, and then her heart rate remains high while she runs. As she decreases her pace, then her heart rate is slowed down and it goes back to the normal rate. So just like the last problem, we need to talk about what are the two measurements that we have here, right? So heart rate is the first one that is mentioned. And I should have said this, but heart rate is the number of times per minute that your heart is going to beat. So different things change your heart rate. Exercise, like in this problem, is going to change your heart rate. Things like if you get nervous or anxious about something, sometimes that changes your heart rate. So if that cute person if your crush looks your way or something, maybe your heart might start to flutter. We'll see. But in this case, it's going to be exercise. So what's affecting the heart rate is her speed, of how fast she's going to run or walk. So just like my other graph, this one's going to start out with this L shape. And as we learn more about algebra, we'll talk about this. I'm not going to bring it up right now, but you may remember some graphs that actually look, excuse me, they look like a big T or like a cross or something. All right. In this case, I'm not going to have anything that's going to be negative, so I'm just dealing with the positives here. All right. So what we have is, and I'm double checking to make sure I got this right. Okay. So, the book actually uses time. I should have mentioned that. So her speed is changing based upon her time. And to be consistent, I could have done it with speed, but I'm going to cross this one out. Okay, so we're going to use the time on the treadmill. But also it's a little tricky because as she's on the treadmill for the time, then she's going to be changing her speed, or the treadmill speed is going to be changing. Okay, so then we're going to measure her heart rate, and we want to find out how her heart rate changes over time as she changes her speed. So first of all, it's being monitored. Let's see, while walking, her heart rate remains the same, so it doesn't go up or going down. So horizontal. So I'm going to underline that. As she increases her pace, her heart rate rises at a steady rate. So then it's going to go up. When she begins to run, her heart rate increases more rapidly. So it's going to go real far up. And then it's going to remain high while she runs. So then it's going to level off again. As she decreases her pace and slows down, her heart rate is going to slow down and return to her normal rate. So then that means it's going to come down like so. Okay? Probably at the same level it was when she was walking. All right? So I know this one was tricky because it talked about whether it's speed or whether it's time. This could have been the same thing. All right? So I will, in the next video, we'll do a couple problems from the practice problems.